Yes, you are.
Yeah, so I'm very fortunate to introduce Priyatos Sir, Dr. Priyatos Datta.
That
So,
counts first.
yeah, Dr. Priyatos Datta got his MSc from University of Burdwan in 1988. He stood first in the national level admission test conducted by IACS Kolkata and joined the PhD program in theoretical chemistry groups at IACS in 1989. Later on, he earned CSR fellowship and associateship during and after his PhD program. He happened to be the recipient of NG Award in Chemistry at ICS for Best Performance as a Research Scholar. He worked for a few months at SN Bose National Center for Basic Science and then joined IIT Kharagpur as a Faculty of Chemistry in 1995. But in 1997, going against the otherwise natural trend, he decided to give priority to life at Kolkata with all of its color over the attractive IIT career. Thus, he left IIT to join Anand Mohan College, Kolkata. Since then, he has been there to explore and prove the common belief that good teachers are born only is a myth. He believes that his research lab is the classroom, research materials are the lively students, passion for teaching and compassion for students is his funding, and the smiling faces of learners is his reward. To him, research methodology is the process of learning and teaching itself. Learning for Dr. Datta is a way of life. In the community of physical chemistry at Kolkata and outside, Dr. Datta is a very popular and known face. One can hardly find a college at Kolkata where he has not delivered some serious subject-based popular lecture. And the spectrum of beneficiaries is broad enough. It starts from school level to the and reach up to university level. Dr. Datta is a very common speaker in refresher course in Jadavpur, Calcutta, and even NEHU, which stands for Northeastern Hill University. Finally, in his own word, he cherishes himself more as a student than as a teacher. Teaching is not a one-way traffic but a dialogue between teacher and students, and the teacher-student bonding is the most popular and fundamental one. So with this short biography of Dr. Datta, so I'd like to request him to deliver his speech.
So, am I audible?
Yes, sir. Yes, sir.
Okay. So, I am going for sharing the screen and then, yeah, share.
Screen is coming, sir.
Screen is coming, right?
It's visible.
Okay. So, let me go to the presentation. Yeah. So, I think you can see.
Fine. Absolutely fine.
Okay. Thanks. Thanks to all of you for being here today to listen to me for just 1 hour. Though already 12 minutes have gone, but that's a typical calculation. So maybe I'll be allowed to take a few minutes more after 11:30. And especially thanks goes to my student Orpon. He has actually taken the initiative to invite me for this session, and he also decided that what I will talk on. He told me that, sir, you are from chemistry, but you will be talking something on mathematics in chemistry. So, the subject, mathematics itself is so vast and no less than chemistry. So, both are very vast and omnipresent. So, mathematics is everywhere. So, if I enter any one of the subjects, mathematics or chemistry, I wonder and I am afraid that it will be typical class lecture, and of course I won't dare to teach my learned colleagues here present. So I have a plan that instead of doing that, what I will be doing, that I am coming to later. And before that, let me just see where chemistry and mathematics do they stand with reference to each other. So let me start from the basic. What is nature, right? And we define mathematically, or you can say scientifically, that the material universe with which we can or can conceivably interact. So that is nature to us. Now then, what is science? It's just an attempt to understand rationally and objectively the reproducible and predictable aspects of nature. or in other words, our attempt to understand rationally and objectively the lawful aspects of nature. Then comes what is chemistry. It is simply study of matter and its changes. And physics, okay, Nobel laureate Rutherford, he told that physics is the only real science and all the rest is butterfly collecting, though many people do not agree with that, but that's a separate story. Then what is mathematics? Like physics, chemistry or biological sciences, mathematics is not a science. Rather, we often call it is the mother, or sometimes we call it a queen or even servant of science. To me, it is like an umbrella. Actually, it covers all sorts of branches or different humanities or science, whatever it is. So that is the versatility of mathematics. Well, let me disclose my plan with a quotation that from Galileo. The most mysterious novel of the universe is the universe itself, only written in the language of mathematics. So you know that is mathematics, right? But the keeping the heterogeneity, good extent of heterogeneity of the audience, definitely I will be not talking on a particular or specific mathematical or chemical topic in depth. Rather, my plan is that what if I just tell a few words, not learning on some specific topic, but on learning itself. That may help you, in the class facing the heterogeneous students. So my plan goes like that. If and as per the timing, if time permits, then a few things. Learning can be fun. That you have to convince your students that learning can be fun. And mathematics is not just an abstract subject, but it can be made visual sometimes. And it is highly interconnected, not isolated some topics, but highly interconnected. And then if time permits, then I would explore a little bit mathematical details of most beautiful formula, and then how we can learn from illusion. So is it okay with all of you, this kind of plan? That learning
Yes,
it,
sir.
yeah,
Yes, sir.
okay. So learning can be fun, really? This child is asking, is it really? So learning can be fun. Actually, I will be talking about a few components of learning. Many components are there. We sometimes remember or sometimes unknowingly forget it. But the components are a few. You can start with solving puzzles, recognizing a false question, thinking out of box sometimes needed, resolving paradoxes helps you, and this is very important, unlearning. You need sometimes unlearning to learn something new, and we can learn of course from our mistakes. So let me go one by one quickly. Solving puzzles. Let me start with some warm-up puzzles, right? It's not mathematical, it's playing with words. So if I ask a question that what has 4 letters, sometimes 9, but never has 5 letters. So you will probably, the students will probably search for this word or that word. They will flip the pages of the dictionary maybe, but it's a tricky question, you know. The answer at best you can say that it's true. It's not a question at all. It's a statement that what has really 4 words, WHAT, and sometimes has 9 letters and never has really 5 letters. So that's a tricky question, and that you can warm up with the students, right? Now a little bit more philosophical, interesting word puzzle. A single word that fills all 4 blank spaces. And now you see, a rich man needs blank. A poor man has blank. If you eat that same word, you die, and when you die, you can take that same thing with you. So it's a very critical, how one can match a single word with all these 4 blanks. What a rich man needs, but that a poor man has, right? And if you eat that same thing, you die. And when you die, you can take that with you. So I don't think there is an answer. Nothing will match with these 4 blanks. Nothing does match, right? So would you agree that nothing does match with these 4 blanks? Or is there any answer? Any one of you, please? I claim that nothing is there as an answer. Yeah, it is nothing is the answer. Now you can match. A rich man needs nothing. A poor man has nothing. If you eat nothing, you die. And when you die, you can take nothing with you. So again, that's attracted me when I first encountered these puzzles. Very interesting. Sometimes you need, as a break in your class to give some of the stuff like this. That from my experience, it helps a lot to draw back their attention. Well, now it's a bit mathematical. Goats, chagol. It's a ghost puzzle, you can say. A man, a diseased, suffering man is on his deathbed almost. He has 17 goats and he has 3 sons. So, as a last wish, he distributes the number of goats among his 3 sons as he mentioned that half of the goats to the oldest son, 1/3 to the middle son, and 1/9 to the youngest son. Now, the problem is that 17 is a prime number. It is not divisible by either 2 or 3 or 9. So, how it can be distributed, right? The question is that. Now, a wise man come forward and he did a trick. He adds 1 goat from his own. So, to make it 18 from 17. Now, 18 is divisible, of course, by all of the numbers 2, 3 and 9. But then you can object that then it is a distribution of 18 goats, not 17. Then it is not as per the wish of the old person. But let me see what happens. So 18 by 2, 18 by 3 and 18 by 9. The 3 sons they got in this ratio, and that sum of this 9 plus 6 plus 2, and that is exactly 17. So there is no problem. They are distributed 17 goats only, but with the help of a ghost goat which is existing but still not there. So I think that's a bit interesting problem for students to warm up sometimes. Well, may I go ahead with this kind of stuff to some extent more?
Yes, sir. Very interesting.
Very
Actually.
interesting.
Sir.
Okay,
Yes,
thank you.
it's very interesting. Please go on.
Yeah, then the second part is recognizing a false question. Often you will see in WhatsApp or Facebook this kind of problems that I have to start with 50 rupees and I spend at few stages, and the first step I spend 20 rupees, so 30 is left, and then from remaining 30 I spend 15 and I 15 is left, and from that 15 I spend in the third step 9 rupees and 6 is left, and at the fourth and final step I spend all the 6 rupees to leave 0. Fine, no problem. Now if you just add, sum up, on the left you will get 50, on the right you will get 51. So the question is, where did the extra rupee 1 come from? It's really puzzling, perplexing question. But actually you are trying to answer a wrong question. We are trying to equate 50 and 51 as if total spend and total balance, but which is meaningless. The total balance itself is a meaningless concept. At best you can say that total spent till a moment and the balance at that moment. So till and at. So if you follow that, then 20 plus 30 is 50. That is always 50 because of that you have started with. And then the second phase you have spent 20 plus 15, right, till that moment. And at that moment it is naturally 15 is left. So 20 plus 15 is 50. No problem. At the third stage 20 plus 15 plus 9 and plus 6. Of course it is 50. And at the end 20 plus 15 plus 9 plus 6 plus 0 is again 50. So there is no problem with the numbers. The equation should be like balance at some point plus total spend at that point, and that must be always 50. So it is also in Bengali we call it jamai thokano proshno. Sometimes we ask this kind of questions. Now the third part is thinking out of box. There may be so many problems, so many examples, but I am just giving one. And I have really tried with the students in my class, particularly from class 11, 12 or undergraduate levels. Really it helps them to get some fun out of that. So the question is that 9 dots are arranged in a form or shape of a square, and you are to connect all those 9 points by only 4 straight lines. Of course, without lifting the pencil and without over tracing. Now what you will after giving the problem, what you will see that the students are very eagerly trying like this, second, third, fourth, and then one is left. So they keep on trying like this, but naturally they will fail every time, because actually you are thinking in a box, inside a box. But if you cannot go outside the box, and someone if tries like this, he starts one line here and the second line is here, and note that it is extended, not up to this point. That is the box problem. But out of box, that means you are stretching beyond that, your imagination, right? And the third point is now again it is a bit stretched, and now the fourth point is this. So you see all lines are connected. Then you can ask an objection that sir, you have not told that we can extend, but neither I have told that you cannot extend. So sometimes, you know, psychologically what happens, students they impose self-imposed questions on the paper, and then try to answer within the frame of that self-imposed questions. But it is not nowhere mentioned that you cannot extend. Only straight line have to be there. So you can easily do that. So that is what is referred as in some of the books, that critical thinking or thinking out of box. And that's a very famous one. Almost everyone knows it. That it came from a 6-year-old boy. He was given the task of adding 1 to 100, maybe some big number also, but I'm taking 1 to 100. And the examiner thought that he will take a lot of time, so in the meantime let me check my WhatsApp, right? Kind of thing. But the 6-year-old boy, after just a few seconds, was trying to give his answer, and the examiner was very irritated. How did you do? It's a pair of undowns, pairwise summation. So what that 6-year-old boy did is he thought that 1 from left and 100 from right, it gives you 101, and the next 2 from left and 99 from right, it again gives 101, and similarly 3 and 98, that gives you 101. So every time you get 101, 101, 101. So that means out of 100 numbers there are 50 such pairs. So it is simply one line multiplication rather than addition of 100 numbers. So he just added multiplied 50 into 101, and he got the answer 5050. And you know, of course, that person later on, that boy, he is a prodigy actually. Later on he became one of the all-time greatest mathematician. Can you guess, any one of you? Can you guess the name of this mathematician? Any one of you, please? Just guess, wild guess.
Gauss.
Srinivas Ramanujan.
Gauss, and one more?
Srinivas Ramanujan.
Ramanujan. No, it is Carl Friedrich Gauss. He is really one. Of course, Ramanujan is all-time great, one of the greatest. But the answer is Carl Friedrich Gauss. Gaussian distribution, that will come later in this lecture itself. So the next point is resolving paradox. 2 equal to 1. There are so many funny childish problems, but this is a bit tricky and advanced, that how you can prove wrongly 1 equal to 2. So let me start with the 2 square is 2 2's, you know, 2 plus 2, 2 times 2. So 3 square is 3 times 3. Similarly 4 square is 4 times 4. So x square is x times x. No problem up to this point. Now if you differentiate both sides, so on your left you will get 2x, and on your right you will get differentiate of ddx of x is 1, so 1 1 1 up to x times. So you really get x times 1, that means x actually. So it gives 2x equal to x. So cancelling x from both sides, 2 equal to 1. So the problem is, what's wrong? Absolutely it is wrong answer, but what's wrong? At what step we have done something wrong? That is the question. In other words, if you do it rightly, then actually we can do that. That x square is x times x, so it should be better written that x into x. Now if you differentiate 2x on your left, and it is a differentiation of product, so x into 1 and 1 into x, that would give you again 2x. So there is no paradox, no problem as such. But since you are taking some false step in some point of your calculation, you are getting a wrong result. Actually the problem is that you cannot differentiate in that way that we have done, that 1 1 1 x times 1, because they are numbers and you cannot differentiate like that. So that is the point where you have done something wrong. Next is unlearning. In my experience, I have seen that so many examples. These examples are taken from my own class experience with students. One such example, that PV equal to C1. I know the chemistry people and many other, almost all of you know, it's 9-10 level science, that Charles Boyle's law, etc. So V by T is constant, volume and temperature of gas, and PV, the Boyle's law, product is constant. So two constants, so you can multiply PV and V by T, PV into V by T, so you will get C1 into C2, that is another constant, C3. But PV into V by T is actually PV square by T is constant. But then it will strike your mind that, yeah, we know of some equation which is actually PV by T equals to constant, which is the ideal gas equation. But my simple mathematical treatment gives you PV square by T is constant. So which one is true? Historically, PV by T is constant. This is absolutely true. But then must be my answer is wrong, PV square by T. So the question is, what's wrong? Where is wrong? Answer is for you, of course, it is very clear, but I am talking through you to some students actually. I think that is the purpose why I am here. So the thing is that you are multiplying two things which are not just mathematical abstract things, but they are some satisfying some condition. When PV is constant, then actually temperature is constant, and when V by T is constant, then actually pressure is constant, which are not understood, which are not mentioned. So when you are multiplying these two, actually you cannot multiply because the two belong to two separate conditions. So you cannot multiply. That is the wrong step you have incorporated in your calculation. And another very simple example, that if you ask any class 11 or I think class 9 students, that what is the volume of 1 mole of ideal gas at STP or NTP, everyone probably will answer that it is 22.4 liters cell. Then you may ask that, have you ever measured? They will keep silent because they cannot. Actually, ideal gas is not available. You cannot purchase it from new market or any shopping mall. So how one can get that? You get it from actually from the equation PV equal to nRT, ideal gas equation, and so V is nRT by P. Now the question I ask, that what are the values that you can put in this equation to really get 22.4 liter? So that is my question, and in most of the cases, at least 90% cases, I get the answer like P is 1 atmosphere, T is 273 Kelvin because that is the STP that defines, and R 8.314. Then I ask them that you please take your calculator or mobile calculator and input the values and check whether you are getting 22.4 liters or not. And then all of say, no sir, it's not coming. The problem is unit. If you please mute all. Okay. So the unit problem, and that's I think as a teacher, everyone has come across this kind of unit problem with students. What's wrong here? They are using liter, right, for volume and atmosphere for pressure. So R cannot be in joules per Kelvin per mole. Actually, R should be the liter atmosphere per Kelvin per mole. But they use the 8.314 value so frequently that whenever they come across putting the value of R, they put it without bothering about the units of the other quantities. They put it 8.314 and they will get a wrong answer. So here you have to be careful about the unit. And if you just put these three values, you will get exactly 22.4 liters. Well, learning from mistakes, often we do this kind of mistakes. So 1 foot is 12 inches. Now let me write in the other way. So if 1 feet is 12 inches, then 2 feet is 24 inches, of course. And 1 by 2, that is half feet, is actually 12 by 2, that is 6 inches. Now we again multiply 2 feet and half feet. So 2 into half. And on your right, you get 24 into 6. That is 144 inches. So we get a excellent, amazing answer that 2 by 2 cancel out. So we get 1 foot equal to 144 inches. But we know that 1 foot is 12 inches. So where it goes wrong? You have multiplied left and you have got the right and right. So equality holds true. Then something is wrong, but where? Actually, it is again with unit. Better you have to write when you are multiplying those quantities with units. So 2 feet and half feet, actually they give you not 1 foot but 1 square foot. Similarly, 24 inches and 6 inches, they don't give you 144 inches but 144 square inches. So if you write in this way, square inches, then it's perfectly okay. So this is, again, I must agree, at least Arpan, you must agree, as far as I know, you're from chemistry, that this kind of mistakes often students do. Do you agree with me? Can you hear me?
Yes, sir.
Yes, sir.
This type of mistakes are very common.
Okay, thank you. Actually, I'm trying to interact sometimes. Otherwise, it becomes very boring. You know. That's why I'm
Yes,
asking.
sure, of course.
You
Of
don't.
course,
You
sir.
don't take it otherwise that I'm asking
No,
questions to you.
sir. Definitely, we should be like that.
Yeah.
We should go like that. Thank
Okay,
you.
thank you.
No
Well,
problem at all.
okay. Now I'm going for the my next part. Maths can be made visual. So this is really very instructive and interesting. I have experimented this kind of full lectures with my students. Uh, let me just give 1 or 2 examples. So the question is that 7 rows and 7 columns, how many balls are there? Any easy way, and you know the answer actually, that okay, it's a kind of matrix, so it's 7 into 7, that is 49 is the answer. But now let me extract something from this simple problem. Let me redraw, but with some partition like this. The first partition covers 1, then the 3, and then of course it is 5, and so on. So actually we are talking about some summation of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. And the answer is already, you know, 7 into 7, that is 49, right? So may I generalize it that 1, 3, 5, if you think of this series, that actually 1 plus second term is 3, third term is 5, that means 2n minus 1 term, right? 7, 13, that is 1, 2, 3, 4, 5, 6, 7. So the seventh term is 13, that means 2 into 7
Recording
minus.
stopped. Recording in progress.
So it is 2n minus 1, and the answer is, in case of 7, it was 7 square. So if you take n number of terms, odd integers, then you should get n square. So that is a very popular familiar formula, a summation formula of sum of the all integers up to nth term, and the answer is n square. But now here you can make it visualize from a simple drawing, simple figure. So that is my purpose, and I will give one more example. This time I am adding not only odd integers but all the integers, even an odd, 1, 2, 3, 4 dot 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 up to nth term. So what is the summation in a formula? Actually, you know the formula, but let me explore from diagrams. So I am starting with the same old diagram, 7 by 7, and now 7 by 7 is n 7 square or n square. Now I am extending how I am adding one extra column here, just extra column. So to make it an 8 into 7 problem or 7 into 8 problem, that means n into n plus 1 problem. And then I do the same trick, that I am putting some separator lines like this. So the first covers 2, and then 4, and then 6, and so on. So what I get is 2 plus 4 plus 6 plus 8 plus 2n. Let me call it S2, whereas my sum in question is S. Now if you take common 2, then it becomes 1, 2, 3, 4 dot 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 n, that means it is our required S. So this S2 is nothing but 2S, but S2 is already, we know that 8 into 7 type problem, that is n into n plus 1. So my 2S is n into n plus 1. So S is n into n plus 1 by 2. So it's a to me personally, it's a beautiful demonstration of a formula by some graph, some drawing. So isn't that interesting? You can explore it with your students, that whether they are enjoying it or not.
Yes, sir. It's very interesting.
Now I'm going on average. On average. So if you ask on average, that if someone asks, hey, can you tell me the average of the numbers? And a mathematician might jokingly say, yes, but which mean do you mean? And we are talking about actually different kinds of mean. At least we know 4 kinds of means: arithmetic mean, geometric mean, harmonic mean, less frequently used harmonic mean, and of course in kinetic theory of gases and many other places we find in statistical units actually root mean square or quadratic mean. So my question is, what is the relative order of magnitude of these four means? And again, you can prove it by mathematical treatment, detailed mathematical treatment. But let me just propose a graphical approach for showing. I'm not discussing in depth, but showing that what is greater than what. So you just think of a diagram like this. So A and B are two numbers, suppose, and you are asking for the mean of these two numbers. So A is this part and B is this part, and then you make a semicircle and you make a radius like this, and which is actually, it can be shown that this is A plus B by 2, because A and B is the diameter and A plus B by 2 is the radius, and that is the arithmetic mean. And similarly, you can show that this hypotenuse of this right angle triangle is actually the root mean square. And if you draw a line perpendicular at the point of intersection between A and B, it is actually, it can be shown again that it is the geometric mean, which is lesser than both these two. And then you make a right angle triangle here, and this purple color length or side, it actually would give you the harmonic mean. So from the figure itself, it is very clear that arithmetic root mean square is the high top, and then which is greater than arithmetic mean, which is greater than geometric mean, and then which is greater than harmonic mean. So now you can give your students two numbers, just arbitrary numbers, they can choose and they can calculate. You write down on the board the formulas and what do they really mean, and then they are asked to calculate the average and see the order on their own. So that would be very funny exercise for them also. For time purpose, I am not explaining this figure. Well, now I am coming to my third part, interconnectedness. You know, this is very, I think it's very philosophical rich concept of interconnectedness, and that comes straight from mathematics. I will show you a picture. I got it from WhatsApp.
Recording stopped. Recording in progress.
It's Bengali. In Bengali, it's written that Jatiyo Puruskar Prapto. It's award-winning figure. Two different faces, but with a single eye, right, and a single feeling. So this is how two people can be interconnected, can feel interconnected. That can be a husband-wife, that can be father and son, mother and son, father and daughter, and so on. And moreover, a teacher and his student. That is more important. So that is a kind of interconnectedness. But before going into the mathematical few points on interconnectedness, let me give you interconnectedness from quantum mechanics or some other subjects of science. We got during the first 30 years of the 20th century, 1900 to 1930, from three great geniuses, Planck, quantization concept. Planck first introduced the Planck
Recording
quantization.
in progress.
Energy of black body radiation, and then we got Einstein, quantization from Einstein. He was in reference to photoelectric effect, and again we got some quantization from Niels Bohr in terms of the matter energy, or in terms of angular momentum quantization. That is every class 11 student now they come across these concepts. But these three quantization concepts were as if three isolated islands, and there were no bridge between these three. That means they were disconnected pearl, gem, but the thread was missing through which we can make a sundar phuler mala, a garland. So we got the three flowers, but the mala was missing. That means the interconnectedness, and that we got from a 27-year-old guy, de Broglie, when he gave his first the wave particle duality in general. Then we got connected. I mean, this Planck, Einstein, and Bohr got connected. So that's a nice example of really that how the different concepts, seemingly different concepts, are somehow interconnected very fundamentally at a very fundamental level. So here is a famous debate between Einstein and Bohr, Einstein and Rabindranath Tagore, etc. But I am not giving the details here. I will just simply say that what Newton says, that if two descriptions are mutually exclusive, right, then at least one of them must be true and one of them must be wrong, because they are mutually exclusive. But what Niels Bohr is saying, that no, it's not necessarily true all the time. Although wave and particle behavior of an object mutually exclude each other, but both are necessary for the full understanding of the object's properties. I call this new situation complementarity. So you will hardly find it in any quantum textbook, but from different kind of books it is there. Actually, Bohr had a dream to write a book on complementarity principle, which is more of philosophy than of physics, but unfortunately he could not finish it. I have a few very special books, that 100-year celebration of Bohr kind of thing, and one on Einstein, and from there I got this few good articles on complementarity. That means it simply says that if two views, two people, two concepts, two political parties, whatever it is, apparently contradictory to each other, apparently exclusive, mutually exclusive, but then you cannot go binary, either this or that. Neither you can reject both of them, neither you can accept as such both of them, but then you can think of something else which is complementary kind of thing, and which embraces both the extreme which are seemingly opposite. You can embrace both and go beyond that to reach something very rich, humanistic something. So you know, in today's world, most of the warfare, starting from your family up to the Cold War, up to the warfare, any kind of war, the thing is that we are not just being able to apprehend, I mean to acknowledge this kind of complementary principle. We are used to say either mandir or masjid, right? But we cannot go beyond that. So that is, even in 21st century, that's a problem, and because we cannot understand Niels Bohr properly. Anyway, another interconnectedness, it is from group theory and symmetry, and that is from a lady, German lady, Amy Noether. The connectedness of three islands are laws of nature, and the inbuilt symmetry in those laws of nature, and of course a conservation principle from physics. As you know, from first law of thermodynamics, it's basically a conservation principle, and there are a few more conservation principles. Now these three were isolated to start with, but after this lady who proposed the theorem, we got that okay, these all three are interconnected. And what is the theorem? Of course, I don't have scope to elaborate this, which I usually do in my group theory PG classes. For every continuous symmetry of the laws of nature, there must exist a conservation law. Or the other way, the reverse is also true. For every conservation law, there must exist a continuous symmetry. So that is how they are connected, you know. Now, I'll quickly go through a few apparently isolated mathematical concepts, but all are fundamentally linked, and I can say that they are like 7 rivers that are merging into the ocean of mathematics, and they are arrangement, binomial expansion, combination, tossing the coins, gambling, even NMR spectra, the error function, random errors, and probability, and all are under the umbrella of, you can say, which is Pascal triangle. So I am going quickly for this part. So let me start with that formula, a plus b square cube and so on, and everyone child knows even the formula. But then if you ask for a plus b whole to the 4, probably they will take some time and fumble and pause. So my question is that how we can easily say any a plus b whole to the power n, right? Now for simplicity, if I just drop the AB wala terms, just take the number 1, 2, 1, 1, 3, 3, 1, and I arrange like this in a same of a triangle. Then the question is that what are the missing terms here? That is the question. And by some pattern, if you follow the pattern, then I can easily show that this is actually 4, 6, 4. Now, any interpretation, how I can do that? So it's talking about actually initially arrangement. So you know that 2ab or 3ab, how they are coming, the coefficient 2 or 3 associated with the terms ab or a square b. It is simply that when it is ab, you have been given 2 boxes, so you can arrange ab in 2 ways, ab or ba. But if it is all a, then only one arrangement, aa, only one. So similarly, if it is 3 boxes and a square b is there, then you can arrange a 2b, aba, BAA, that means you get 3. So somehow it gives you a connection between the arrangement problem with this coefficient 3 or 2 here. This is all about the arrangement. Any direct formula for that? I think you know, actually they are talking about binomial expansion, right? A plus b whole to the power n is nothing but binomial expansion, and you know the binomial coefficients formula. But that formula is again nothing but coming from combination, that how many ways you can arrange R objects taking from n objects, etc. It's a permutation combination, you know, everyone, and the formula is simply factorial n by R factorial n minus R factorial. So you get connected. I mean, all the concepts you can easily generate all the data from Fortran programming. That would be a good exercise. Usually I do this kind of exercise with my UG and PG students. So the fourth point is that actually the pattern that I am talking about is a Pascal triangle. So you know, everyone Pascal triangle, that 1 start with 1, then 1 1, and then in between the term 1 plus 1, that is 2, and then in between 1 and 2 it is 3, 2 and 1 is 3, 1 and 3 is 4, and so on. So you can go up to any number of rows and you can get the full numbers, and this number set is actually the set of in your formula a plus b whole to the power n. And actually they are the problem associated with the arrangement, and actually they are the combination formula, and actually they are the binomial coefficients. So everything is connected under the Pascal triangle. Again, you can generate by simple program this triangle itself, and then you can have a good beautiful plot using Excel. That would be also a good exercise for students. And as you know, if someone is there from this audience, organic chemistry people, then of course there must be one or two. And you know that Pascal triangle is actually exactly used for NMR spectra splitting ratio, that in a triplet this peak ratio is 1:2:1, that is the 1:2:1, the third row of the Pascal triangle. And if it is quartet, then 1:3:3:1, so that exactly is 1:3:3:1. So somehow, and there is a logic physical argument behind that why the splitting is like that, but my point is that you can get it from a Pascal triangle. So it connects even to some problem of chemistry. Now I was talking about Excel plot. If you go really for plot, say n equal to 10, a plus b whole to the power 10, and you take the binomial coefficients or the term in the 10th row in the Pascal triangle, you can have a chart like this, right? A discrete distribution, of course. And if you increase the number of n using a computer program, you can easily generate, and using Excel you can easily plot it. So you will get this kind of plot. And even if you increase, go on increasing, so n equal to 1000, then you will get a curve like this. That means they are very close now, and if you jump from discrete to continuous, almost n is infinity, then this curve is actually represented by this kind of function. And this is one of the very important mathematical equation, Gaussian distribution. So it is relevant to so many of physical problems. I am not going to that. And then this is connected actually again another problem is gambling, that suppose you have been given 4 coins and you have to toss, and then the question is what you will bet on. There are 5 possible ways, 4 head 0 tail to 0 head 4 tail, and in between 3 head 1 tail, or 2 head 2 tail, or 1 head 3 tail. And if you take h equal to 1 and t equal to -1 for convenience, then the total value is 4, 2, 0, -2, -4. Now the question is, if you are a gambler, then what you will bet on which particular combination or on which total value? That is the question. And if you know this discussion, if you know that essence of this today's discussion, then of course you will bet on some particular, not on any other, and that which one is the answer that you get easily from probability. So now I can say that gambling, coin toss, arrangement, binomial expansion, combination, Pascal triangle, all are actually merging gradually to the ocean of mathematics. And the probability concept, you know that actually 4-0 combination you can arrange only in one way, and 3-1 combination can give you 4 possible ways of arranging. Similarly the other way, and you know the definition of probability, and that is the number of events of that particular event by total number of events. So the total number of event in this toss problem, gambling problem, is 16. If you add 1, 4, 6, 4, 1, you get 16. So probability of any one particular event is of course that number of distribution, number of ways of arrangement by total number of ways of arrangement. And obviously this is h, 6 by 16 is the maximum one, 6 by h. And interestingly the ratio is 1, 4, 6, 4, 1. That is a plus b whole to the power 4, the formula h4 plus 4 h cube t, and so on. So it is again connected to the combination problem. So that is really related to gambling, but this same gambling problem actually is very popular and famous problem in analytical chemistry. Again, I am referring the chemistry people present here, that everyone knows that in analytical chemistry we talk about some error function, right? And nothing but they are same as the Quantos problem. In that case, we say that suppose we have four possible errors, and the errors are either +1 or -1 unit, right? That means plus head and tail kind of thing. So again, you get 5 combinations. So now the question is, what is the best probable or most probable error that you can have? And exactly the same question and the same answer and the same rationality comes from probability, and that again it leads you to the same Gaussian distribution, and this is related to this error problem, and probably that's why it is sometimes called connected to error function, right? Error function is okay, of course, something different, but connected to this. So that is the Gaussian, and you can play with this Gaussian plot by Excel by switching over the two parameters sigma and mu, and you let them see how the graph changes, area and the width, etc. So that is an interesting Excel demonstration. Now I will take a few minutes more to almost my last part, the most beautiful formula. So we have heard of most beautiful many things, but formula. So let me go through very quickly a quiz. So if you please interact one or two of you promptly, then it would be better to go on. So it's a quiz time, but the answers is not unique. Okay, answers are not unique, so you can give any answer. My question is that what is common among the images that I will show next, 5 or 6 images quickly. So what is common, right? That is the question. So just have a glance of the images. A beautiful natural scene, another jharna, fountain, a famous Michelangelo piece, another natural beauty, and this is one of the all-time great, most beautiful lady, Audrey Hepburn, and of course this is our Dada Maharaj, the majestic updrive. So my question is, what is common among among the 6 images? So just quickly, can you respond to this? Okay,
Sir, can you go back the slides a little bit?
Can you quickly show us those?
Okay, I am showing it again. The first one is this one.
Okay.
The second one is this one. Third, Michelangelo drawing. Fourth, another natural scene. Fifth is really a beautiful lady, Audrey Hepburn. And the sixth one is our Maharaj, updrive. So now the question goes
yes.
Something
So
is
it like
symmetry, any kind of symmetry, any pattern is being followed?
Okay. Any other answer? I told that answers are not unique. You can give any answer.
So it's like a flow or something.
It's like a flow something, but Audrey Hepburn is static.
They're all good to look at, like they're very beautiful.
Yes, thank you. So this is the answer actually. It's not an unique answer maybe, but I think this would be the unique answer. No other answer can be as unique as this one, that they are beautiful, the most beautiful. Of course, the question that why it is beautiful, why something is at all we call beautiful, and more importantly, what is that beautiful formula, right? Actually, beautiful formula is connected with some things which are a bit mathematical. Infinite series, Geno's very famous, historically famous and philosophically famous Geno's paradox, and then typical to mathematical expansion, Taylor's and Maclaurin series, which nowadays we study in UG level as well, and all these things are being played by a genius. So let me quickly, I have a few minutes, so let me quickly go through these things. That infinite series, suppose you want to add like an infinite. So the question for an infinite series, is there any finite answer? Let's say for example 1 plus half plus 1 by 4, and it goes on and on and on up to infinity. So is it that the final answer is 2, which is a finite number? At one time it was really an unanswered question, but now we know from convergence and divergence, etc., that some of the infinite series may have, if they convert, they may have some finite answer. Now in a connection to this problem, let me show quickly the Geno's paradox. What it is, I think you have come across this paradox, everyone knows, but let me present it. It's a race between a hare and a tortoise, right? A slow moving tortoise and a fast moving rabbit. So the rabbit says that since I run twice as fast as you do, I will give you a half-mile head start. So he says, okay, thank you, boss. And then it starts, this is half-mile ahead. The tortoise is half-mile ahead than the rabbit. And then ready, steady, go. Starts the run. Now, the hare quickly reaches the turtle's starting point, that means this point. But in the meantime, the turtle moves 1/4 mile ahead, because it's half of the speed is that of the rabbit. So at the time it goes half mile, it goes 1/4 mile. So again the next moment it will come its original position, but again by that time it moves another some point, some position, right? So it goes on. The logic is that no matter how quickly the hare covers the distance between himself at that point and the turtle uses that time to move ahead by some extent. So in principle, the hare or rabbit cannot catch the turtle. So can the hare ever catch the turtle? It was a famous question by Zeno, the philosopher Zeno, long back. Actually, he knew nothing about the infinite series at that time. So how can I ever catch the turtle? And it is actually if you follow the distance, it's like a summation, infinite summation. So the same question I'm putting, that what is the answer to this question? And yeah, resolving the paradox, actually we can easily calculate that if the runs twice as fast as the turtle, then the rabbit runs 2 miles in the same time, the turtle runs 1 mile. So the answer is actually 2 miles. It should be 2 miles if it starts 1 mile ahead. So that is the answer that we know now, but at that time it was not that easy. Okay, so the answer is 2. Now let me go for a quick graphical demonstration of the same formula. It's very pleasant to look at, graphical. So let me start with a square of 2 square units. Okay, suppose the area is 2 square units, and I divide into 2 parts, one the red 1 square unit and the gray one is that 1 square unit. Now what I do, the right side one I make it half and half. So it is this is 1 half and this is 1 half. Now again I do the black one, again half. So I get 1 by 8, 1 by 4 and 1 by 4, black one. And this black 1 by 4 again divided into 2, 1 by 8 and 1 by 8, and you go on dividing 1 by 16, 1 by 32 and so on. So what we see that the size of the square is going on decreasing, and finally after infinite times of such divisions, actually you are converging to this corner point. That means actually you are covering the whole beginning square, and the area you know that is 2 square unit. But what you are doing in your process, you are actually taking the sum of 1 plus half plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 and so on. So the answer is 2, because actually you are dividing the basic beginning square, which unit is 2, that we know to start with. So it's an interesting graphical explanation of that very famous. Now what is the beautiful equation that I'm talking about, and how did we get it, why it is beautiful and so on. So I'll skip some of the slides here because of time restriction. And what is that beautiful formula? I think you know. Do any one of you, is it here that who knows that beautiful formula? Have you ever heard of any most beautiful formula? Any one of you? Either yes or no?
Actually, I want to say that is in complex analysis, that Euler formula.
Exactly. So thank you very much. This is that formula you are talking about, e to the power I pi plus 1 equals to 0. So I will not explain how Euler did his trick, genius trick to get it from Taylor and Maclaurin series actually, but I am just referring as the equation. So I am skipping some of the, this is the Taylor expansion, and Maclaurin expansion. These are typical mathematical expressions, so I am not bothering about those detailed mathematical expressions. And the thing is that by a little bit of mathematical manipulation, starting from e to the power x and sin x and cos x expansion by Taylor series, one can get this formula, of course, by some tricky steps which Euler made very boldly at that time when it was not very aware with. People were not very aware with all these things. And finally, he got e to the power I by -1. But let me just tell you why it is beautiful. Because first of all, it involves all the important operations in a single equation: addition, multiplication, and exponentiation. And moreover, it connects the 5 most important constants in mathematics. Everyone will agree, particularly from maths department, that yes, these are the most important numbers: e, pi, I, 0, and 1, and all are involved in a single equation. And more importantly, it includes 4 different branches of classical mathematics: arithmetic, algebra, geometry, and analysis, all in a single equation. So that is very interesting, and actually it was really voted by physicists and mathematicians as the most beautiful equation. And these are the series, I mean, examples of few examples where chemistry people will like probably, particularly physical chemistry people, that where we use this Taylor and Maclaurin series. Probably only one person would be interested here, only Arpon, or maybe 1 or 2. So I am leaving this part. References, and then the last point, illusion. So I can sometimes learn from illusion. Everyone, illusion, what it is. Say for example, visual illusion, audio illusion is also possible. So what I show it to you, what are they? You may answer that they are looking like inverted broken plates or broken pizza, right? And do you find anywhere a triangle? No. But if I say, after rearrangement of these 3 figures, you can see, can you see a triangle? If you please respond.
Yes, yes, sir.
Yes. So my point is that why it's illusion, because the triangle is not really there. I have never drawn a triangle over there, but it looks very visible, a triangle, right? But the triangle is not there. So something is not there, but it is visible. Then you can go the other way, that something is there, but you cannot find it. You cannot visualize it. So if I now ask the question that can you see anything inside the triangle? Can you see anything inside the triangle? Yes or no? Any word, any figure, any diagram? Inside the triangle only. Yes.
It looks like a square. Is there any?
Inside the triangle, do you find a square? No.
Inside the triangle, there is a triangle also.
T type.
Inside the triangle, I think you don't find anything.
No, there is nothing.
No, actually, nothing is there unless you expand your heart. It is really something is there inside the triangle, but that is only the heartfelt something. You cannot see by your open eyes. It is something there on the basis of heartfelt, because it is there. You see, this is there. So thank you very much for your patient hearing and allowing me a few more extra minutes. Thank you very much.